All right, calculus friends, I'm going to talk about critical points again. And the website at the top of the page, I thought it was very helpful, so I put it on there just in case you wanted to try another way to go. So when we talk about critical points, we're talking either about local maximum or local minimum or an inflection point. Okay, and so what we're talking about is here's your local minimum, right? That's your parabola. Local maximum would be like this. And an inflection point is like that, where it changes concavity. Remember, concave up is that side. This side is concave down. Now, sometimes a function will have all of them in there. Here's your minimum, here's your maximum, and in here somewhere is your inflection point because it changes from being curved this way to being curved that way. So we're going to try to talk about that a little bit and see if it can make any more sense than what it did the first time. I don't know. All right. So the first derivative test, remember, tells you the slope of the tangent line. Okay. And so the first thing I did with this example is I took the derivative. So x to the third plus 3x squared minus 9x plus 4. When I take the derivative, I get 3x squared plus 6x minus 9. Okay, so now I want to know where the first derivative is equal to 0. Because when the first derivative is equal to 0, that's where I'm going to have my maximums, minimums, or inflection points. Okay? Might have, who knows. So I picked this one so that I could easily find it. So x equals negative 3 or x equals 1. So then I made a number line, and I'm going to highlight as I talk. Negative 3 and 1 were the 2 points that I had. So I found the first derivative value of a point to the left of negative 3. I picked negative 4. A point between negative 3 and 1. I picked 0. And a point to the right of 1. So when I did that, I ended up with a positive, a negative, and a positive. By the way, the reason we have to do this is I realize you can just graph it. But on your final, sometimes you're not given the function, you're given the derivative, or you're given something else, and you have to kind of go backwards, but you don't really have all the information. So that's why we have to kind of know about this. All right, so I drew arrows here because if it's positive, I know that it's, a positive slope. And then if it's negative, I know it's a negative slope. Notice that's a maximum when that kind of thing happens. So there's a maximum at x equals negative 3. And then this side over here, since the next one went up, notice right here, this is like a minimum at x equals 1. Okay? So, and I have a third degree, so that doesn't surprise me that it would kind of look like that. Okay? Now, what about inflection points? All right, so to do inflection points, you have to do the second derivative. So I'm going to do the second derivative. So I wrote the first derivative over here, and I did the second derivative. 2 times 3 is 6, x to the, down 1, and then 6x, the derivative of 6x is 6. So I set that equal to 0. I factored out the 6, so I don't have to worry about it, and I get x equals negative 1. So remember, the second derivative tells you whether it's concave up or concave down. So I picked a number to the left of negative 1, which I did negative 2. That was a negative value. And then I picked a number to the right, was a positive value. Since it's concave down, then concave up, there must be an inflection point at x equals negative 1. So once I do that, I would then go back, and if I have the function like I do here, I would graph it and see if all those things match up. And they do, so you're like, woohoo, way to go. All right, so here's another example. I have x to the fourth minus 2x to the third. All right, so I'm going to do my first derivative, and that's 4x to the third minus 6x squared. Okay, I set that equal to 0. And then I solve for x. I factored out a 2x squared because I could, makes it a little bit smaller. So that means x is either equal to 0 or x is equal to 3 halves. So then I plugged in values here. I did the number line thing again. And I picked a number to the left of 0, which was -1. And I got me a -10. And then I picked a number between 0 and 3/2, which was 1, which got me -2. Now notice, both of these are negative. So negative, negative, that means I do not have any sort of maximum or minimum because they're both in the same direction. Okay? And then I picked a number to the right and it was positive. So if you go from negative to positive, that's going to be a minimum at x equals 3/2. Okay. Oh. You might have to listen to this again and stop it and kind of make sure it makes sense in your brain. So now I have my second derivative. Do I have any inflection points? It is an x to the fourth problem. X to the fourth, it could be a variety of things, who knows. So I'm going to do the second derivative, and I have my first derivative is 4x to the third minus 6x squared. Take the derivative, I get 3 times 4 is 12, so 12x squared minus 2 times 6 is 12, minus 12x. I'm like, oh. So I factored out a 12x to make everything a little bit smaller, and I have 12x times x minus 1. So I have those two values. Now look right here. This is kind of important. 0, 0. Sometimes the same number shows up twice. Once in the first derivative and once in the second derivative. Not always, but sometimes. So notice when I did my line here and I put in my values, this was a positive second derivative, a negative second derivative, and a positive second derivative. That means I have a concave up, a concave down, and a concave up. So that means I've got some inflection points. So I have an inflection point at x equals 0. So notice over here when x equals 0 for the first derivative over here, I didn't get any maximum or minimum because they were both the same direction on either side. So you never know what's going to happen. Okay, could be a maximum, could be a minimum, could be an inflection point. And I think this is the last example. So I have y equals x to the fourth. So I take the derivative of that and I get 4x to the third. And I solve that, I get x equals 0. So I have to the left and to the right, negative, positive. So negative is going down, positive is going up. So there's a minimum. But notice over here, when I do the second derivative, I also get x equals 0. But now notice there's no inflection point because both of these values were positive, the left and to the right. So that means they're both concave up. So that's not an inflection point. It's just whatever. And you know from your amazing knowledge that y equals x to the fourth looks like a parabola, but it's kind of got a flat on the bottom because you've got all four roots being right there. So it's flatter than if I had y equals x squared, which would be more pointy. Okay, well, that doesn't make any sense, I know. So anyway, good luck with that, and we'll talk some more about it later.